there are two very different ideas of what order even means. There's the common idea of order and one used mainly in sciences. And unfortunately, these two ideas are entirely incompatible with each other, which causes lots and lots of confusion. So I guess the common idea of order is that something is ordered if it's highly symmetric or if it follows a strict set of rules. The problem with this idea of order is who gets to decide what these order-defining rules are? Imagine my room was very messy. I don't have to because I can see the other half of the room. But now instead of cleaning up, I write down a rule. I measure where everything is exactly. I measure where every dust particle is located. And then I make a rule that that is exactly where everything is supposed to be. Then wouldn't that be the most ordered room? A room where every dust particle is exactly where it's supposed to be. Of course, other people would still consider my room to be very disordered. So again, how can we measure order if we can't agree on which rules to apply? And that is where this second idea of order comes in. It attempts to do exactly that seemingly impossible thing, to measure order without even settling on specific symmetry rules. The basic reasoning is if a room is messy, we don't even know where everything is. We don't know nor care where every dust particle is located exactly. We consider it to be messy when things are all over the place. In our perception, it's kind of a blurred state. For example, if I spill a box of marbles on the floor, my idea of the state of the room is not, oh, there's a marble at exactly this location and here's a marble at exactly that location. My idea of the state of the room is there are marbles all over the floor. And that is associated with a certain large number of possibilities how the marbles could actually be arranged. The logarithm of this number of possibilities, by the way, is what we call entropy. And now, if I, for example, compare this number of possibilities, how the marbles could be arranged on the floor, with the number of possibilities how the marbles could be arranged only inside this box, then I would find that this number of arrangements in the box is a lot smaller. And consequently, I could argue that marbles distributed on the floor is more disordered, has a higher entropy compared to marbles being confined to this box. However, it's very important to see the crucial difference between these two ideas of order. We started with this symmetry idea of order, and that's something we can apply to the actual state of my room, no matter how detailed the description is. Following this second idea of order, however, the entropy idea of order, order is no longer a property of the actual state of my room. It's a property of a distribution. It only works for an incomplete, blurred description of my room. Marbles distributed all over the floor, for example, is not the actual microscopic state of my room. It's a distribution of possible states. And that is something that has entropy. The way how the marbles are actually positioned in my room is not. That is just one state, at least if we don't go to the quantum level. So in one case, order is a property of a microstate, and the other case, it's not. It's a size of a distribution. And that's why, for good reason, it is frowned upon if entropy is simply introduced as a measure of disorder, because that's when people mix up these two very different ideas of order and usually remain confused about entropy for the rest of their lives.